Synthetic division. Synthetic division, guys. Synthetic division only works when you're dividing a polynomial by a binomial with exponent 1. Okay? Polynomial by a binomial exponent 1. That's when synthetic division is going to work. So we've got an example. So right now it's a 100% pencils down, eyes up moment. Open your page up to in your notes to the synthetic division page. You have to look off Caius for now. We have x cubed plus 4x squared minus 3x minus 5. Okay. We have this. Now the first thing we're going to do is you have to understand, guys, if we had a factor of x plus 3, what do we set that factor equal to? If I were to ask you to solve this, so if you're looking at the barn question from yesterday, what did the x end up being for the barn question yesterday? You remember? 16. How did we get that? How did we get that? There you go. We set it equal to 0. We got x equals 16 because we had x minus 16, Gabriela, as a factor, and we took x minus 16, set it equal to 0, solved, and we got x equals 16. So the first thing you'll notice on synthetic division is I put a negative 3 in a little box. I get that because x plus 3 equals 0, so x equals negative 3. If I have an equal sign, that's exactly what I put in the box. If I'm given the entire factor, then I put the opposite in the box. It's kind of a quick rule, but it's not always true. For now, let's go ahead and do that. So I put negative 3 in the box. Everybody okay? All right. And then I write down every coefficient. What number's in front of that x cubed? 1. What number's in front of the x squared? Negative 3. Careful. All right. So I write down the coefficients. Okay? This is in your notes, by the way. Yeah, just so you know. Okay. Okay. First thing I do, I drop down that first number, no matter what. Now, this algorithm doesn't change. Don't lose the algorithm. Multiply, add, multiply, add, multiply, add. Negative 3 times 1 is 4 minus 3 is. Negative 3 times 1 is. Negative 3 plus negative 3 is. Negative 3 times negative 6 is. 18 and negative 5 are. Okay. That means something. I have, at this point, divided x cubed plus 4x squared minus 3x minus 5. I have divided it by x plus 3. If I divide x cubed by x, what do I get? X squared. It goes down a power, yeah? So this means 1x squared plus 1x minus 6 with a remainder of 13 over x plus 3. That is the work that's on the right-hand side of that note. Polynomials, page 11. Savannah, what was the last page number you left off on for polynomials? 7, so you need 8, 9. Well, 6, 7 you have, right? All right, 6, 7, 8, 9. You missed some bad days, Savannah. Colin. Remainder is always the last number. A lot of times, Colin, what I do when I write these, it's just a habit I have. I tend to put that. So if you ever see me do that, don't think, wait, what are you doing, Mr. Bates? I put a little bracket there so I always know what I'm talking about with the remainder. That's just something I tend to do. All right, really quick. I wanted you to say, Mr. Bates, prove it. Thank you, Michael. Okay. X plus 3 goes into x cubed plus 4x squared minus 3x minus 5, right? So I go x squared, distribute, subtract, cancels, get x squared. Okay, goes x squared goes x goes into x squared, x times, distribute, subtract, cancels. X goes into negative 6x, negative 6 times, distribute, subtract, remainder. Okay? So, synthetic division does it. Holly?
How do you know if there's a remainder? Like, is it always just going to be
If
very
it's the very last number.
Okay.
So if that last number is 0, so huge concept, because some of your questions, they are the exact same question. We're going to do these on the workbook. Okay? The question is the divisor, or it'll say, is this a factor? If you get 0 at the end, yes. If you don't get 0, no. Cameron.
So, like, when you do it, like, using synthetic division, like, I understand how you got the variable and the power for the first number, but I don't get how you got, like, the x, or, like, what happened. Like, I just don't get how.
I need a full sentence, please.
Okay.
At some point, finish it.
Okay. Because there's the 1 and the negative 6. I don't understand, like, how the variables carry out to those without having to do, like, the division in your head.
So, I'm always dropping by 1 power. I started at x cubed. You good with that?
Yeah.
That makes this x squared,
Yeah.
which means the next one's drop a power, remainder, until you hit the remainder.
So that's how
You-
it's going to be for
You always just keep dropping a power as you go to the right.
Okay.
Keep dropping a power as you go to the right. And guys, all these numbers popped up. I want you guys to see that. Negative 3. Negative 3. Negative 3. Negative 3. Positive 18. Positive 18. It's all in there. It all works out. Alrighty. This is the same thing as something called synthetic substitution. You'll remember, I'm going to try to make a slightly easier version than back in the day. Well, than I did third period, I mean. Let's say that I had f of x. You don't have to copy this down. This is just like a look-see thing. If I say f of x equals, you guys hate multiplying by what number? 7s. That's a pretty common one, okay? 7x, we'll say cubed plus 9, Kelsey said, x squared minus, actually, let's make this one a minus right here. Minus 9x squared plus 3x minus 4, okay? And back in the day, I might have said, what is f of 4? What's f of 4? Okay? Which means, what's f of 4 mean? For every x, you write a 4. Okay? So here you get 7 times 64 minus 9 times 16 plus 12 minus 4. So you get 448 minus 9 times, see this, 90 and 54 minus 144 plus 12 minus 4. So you get 304, 316, 312. Whew, okay. How many of you guys been able to do that fast without a calculator? Okay. I stumbled a few times, right? Had to stop, think about it. If I simply did this, now this means x equals 4, correct? Correct? The answer is yes. So since it's an equal sign, I could put that in the little box. And I could put 7, negative 9, 3, negative 4. 7, 28. We good? 28 minus 9? 19. 76. 79. So that's 316. 3/12. So if you're using synthetic substitution, your synthetic division will do the same thing, and your remainder is the solution. Sione? Yes, the first number always drops. Faster. Now, you guys might not like these numbers as much either, but at no point did I have to do 4 cubed times 7, 64 times nothing that big. Yeah. Yes, it's multiply, add, multiply, add, multiply, add.
I hate that. I like this. I thought I hated it, but then I remember when we started doing it, I did like it.
I thought I hated it, but then I remembered I don't.
Yeah.
That's a cool story.
It looks complicated. That's why I said I hated it.
No,
Then
I never even learned it last year because I wasn't here.
That whole section about it.
Yeah, I wasn't here when he taught it the first day, and then like he used it later, and then we were like, you don't know it, and then he'd always look at me, do this, and so then I always had to do the same.
What, you're saying that if a student doesn't know something, I might tend to pick on them and look at them every time I mention that they don't know how to do something?
Well, you did and I did. I'm not speaking for everyone.
I like that about you, Bethany. I like that. All right. You all right, Holly?
Yes.
Did she poke you in the head with a pencil?
Yes.
Kalani? All right, guys. Number 5. Number 5. What do I put in the little box? No. No. 2. Did they say 3 that you schnicker? 2. I'm saying for the most part you put down the opposite number. When is it not just the opposite number? If this had a coefficient in front of the x, and you're not going to see those right now, so it might be an extension problem on your homework, but all right, what do I put down here? What's the first number? 3. Negative 8. 4. Okay. 3. 6. Negative 2. Negative 4. 0. It is a factor, and the answer is 3x minus 2. The solution is 3x minus 2. So that whole thing, 3x squared minus 8x plus 4, divided by x minus 2, the answer is 3x minus 2. And those of you who asked the question, so like Cameron, you could see, this was an x squared. So the solution dropped a power, and then I keep dropping a power as I go to the right. Holly, you had a comment?
I said this one's just easier.
Right?
Yeah.
Negative 3. 5. Negative 4. 12. Now, on these guys, don't forget if you have to watch out. If it skips one, you do have to put that 0 in. Now you have to. You can't. It's not optional. The 0 has to go in if it skips. This one, none of these skip. That's why I have to say it verbally right now.
If the ones with the 3 skip, right? Basically, right?
I mean, no. If I had that one skips because it skipped the x in the middle. Okay. Five. Negative 15. Negative 19. 57. 69. This one has a remainder. Do you say
I said, Wait, Mr. Bates, I thought there used to be more steps to this, or is that just in pre-calc? Didn't we used to like do something like got 0 or something?
Oh, find all the factors. So remember, yes. So at some point, this will rational root theorem.
I'm thinking of that, and I was like,
You remember?
what steps is this, and you're not doing it.
Do you
and I was
do you
like,
remember? You remember the Q's over P?
Yes. And I
Q
was
over
like,
P. Find all the possible rational roots, and then you've got to try them.
That's where I said,
Okay. Okie dokie. Why don't you guys try number 7 and 8 really quick on your own? Okay. Hey, Cameron. You have a question. Huh?
Okay, I got it.
Because this only works when you're dividing by a binomial of exponent 1. Yeah. So if you looked at our long division problems, a lot of time it was like a cubic divided by something squared. So. Alicia, Beatrice, Pishamoon, have you guys ever seen this? Yeah? Yeah? No. Martina was like, nope, never seen it in my life. And then she's like, neither has Alicia, neither has Beatrice. And I was just like, really? And she's like, yeah. Yeah, I stalked them pretty hard in Italy. And I always know exactly what they're doing and whatever they did. So. Where are these two? This is a bad day for them to miss.
Destiny's sick, and then Natalia loves her.
This is one of those things like when you look at it, you're like, I don't even know what's going on. It's like one of those intimidating visual things. If somebody just like walked in and was like, here's how you do number 7. So you're going to put 9, then you put 9, then you put 2, then you put 2, and then you put 5. And of course that makes 9x plus 2 with a remainder of 5 over x minus 1. I know. I don't know. I don't even know how I did it. I just made up numbers and I put them down there. And if you say them with enough confidence, people think you're a math teacher. That's really obnoxious.
Remember that episode of Beavis and Bert where Isabella had hiccups the whole day? And when they tried to scare her?
Wait, Mr. Bates,
Yeah.
number 7, isn't the one negative?
Yeah?
So, wouldn't they one negative?
No.
No? It's just a positive?
Yeah.
So, even if it's negative, it's positive?
Yeah, because I'm saying x minus 1 equals 0, so x equals 1.
Oh, okay.
So I put a 1 there. Alrighty. Any questions? Can I move on? Anybody need another minute?
I need another minute.
Okay. Can it be more like 20 seconds?
I'm no. One sec. A couple days for you have to maybe on that 6 then you multiply -7 -6. Then that 47 times -7 equals -329. That's where that comes from. Okay. Thanks.
You good?
Sure.
Oh.
That took like 20 seconds.
Oh, good job.
Can't really see.
Ew.
That's not even a realistic one. Yeah.
Too realistic.
Not right now. So she Everybody make aggressive eye contact with Mr. Bates.
I don't even know if you're capable of aggressive eye contact.
I can't.
Nope. Okay. That's enough of that, Holly Ross.
I'm sorry.
Yeah.
I'm trying. It doesn't work.
All right, guys, since these say equals on 9 and 10 when you're doing the synthetic substitution, since it says equals, you don't change the sign. So for number 9, you're literally putting 3 in the box. If you what? Yes, if I asked you to do this using synthetic substitution and you did not use synthetic substitution.
I can't even, like, my brain
Process what?
This.
What?
It's the same thing that we're doing, but I don't get it.
What don't you get?
It.
You got to help me more.
So I know how to like set it up and everything.
Uh-huh.
I don't know how to like put it into the final answer.
That's
I
on the
guess I do. I'm just dumb.
You are not.
It's always gonna be that remainder. What if there's no remainder? Then this equals 0?
Yep.
Yeah, not you. Oh. Wait.
Yeah, it's what number 11 and 12 are the same thing. Is it a factor? It's if I end up with a 0 right here, yes. No 0? No. Sorry, I'm so boring, Riley. It's okay. She forgives me.
Oh.
So benevolent of you.
I couldn't see.
Can you see clearly now? The rain is gone.
So is the fog.
I got confused.
It was so cool. It happens like once a year.
It was like a horror story.
Oh my gosh, Mr. Bean, I was driving to school this morning and I just winged it. I had no idea what I was doing.
Guys, quiet down. I know this is easy. Yes, Nicole. No. That's a method that you can use later in the year, but since we're doing synthetic to solve, we have to use this method for this section. We've got to learn multiple ways, and then we can decide later afterward. Okay? It's like like a good little example on why we learn it both ways, and then I force it one way for now, right? Because this is not me saying you can only do it one way and otherwise I'm mad, because I hate math teachers that do that. But like think about it as a kid. When you're a little kid, like Holly, right? So, no. But when you're a little kid and when you first are getting in the car, you learn to get in a car because it's so big. You have to put your knee up and you have to crawl up onto the seat, right? And then you get a little older, but you're still going to put your knee on the seat first. A couple of my boys, I think, still, when they get in the car, they go head first, put their hands on the seat, and then like slowly sit down. But and then as I get after them for them, like, no, you just step in and sit. And they're like, and then they go, can I just do it the other way? No, you're not allowed. And then eventually it gets to the point where I was like, oh, this was way easier. I don't know why I didn't do this forever. And it's because you grew up as a little kid having to crawl into it, so that's just what you're used to.
Isn't it wild that like we can't see where the counters when we were little? I think that's
I know.
cool.
Just
Like I always
well, no, nobody has. This is new for 100% of the class, except for Alicia and Beatrice. Huh?
I just learned this one.
Oh. Okay, guys. I'll have lots of